Okay, so let's finish up with some few more definitions, but once again, it all kind of goes into some problem solving. So when you're getting ready for the assessment, it's going to be problem solving. So just make sure that you're prepared for that. So second law of thermodynamics is going to talk about entropy or disorder. So what this says is that all spontaneous, and so remember we're talking about whether or not um, a reaction is going to happen. So when we're talking about spontaneous, it's whether or not it's going to happen. So all spontaneous or natural processes there we go, squeeze it in there. All spontaneous / natural processes um, increase the entropy of the universe, which is kind of a big time definition. So all spontaneous or natural processes are going to increase the entropy of the universe. So what the heck does this mean? This means that if you have something that has a positive delta S, it's more likely to be spontaneous. Not guaranteed, but it's more likely, right? So what does this formula do? And this formula is right here. What does this formula do? What does Gibbs free energy do? Well, what it does is it combines delta H, which we've looked at, delta S, which we've looked at, and temperature. So it's combining three things. And if we look at three variables, how hot or cold something is, how much energy did we add, is it spontaneous or not, does it have an exothermic or an endothermic delta H, we can determine whether or not the reaction is going to occur. So it's kind of like taking all the things we've done in this chapter and adding them up into one formula. So it is guaranteed to be on the test. And so we'll talk about that in a minute. So this is going to combine entropy, enthalpy, and temperature. Entropy. So let's put enthalpy first. Now, remember, it's a fancy word for delta H, right? So that's what enthalpy is. It's just delta H. So enthalpy, entropy, be nice if they didn't both start with E and almost sound identical, right? And this one is delta S. So we're going to Gibbs free energy is going to be a value, and the value is going to be delta G. So maybe we should note that as well. So delta G is going to be enthalpy, entropy, and temperature. And so what this is going to do for us is tell us if something's spontaneous or not. So we've got the enthalpy change and entropy change, and then the temperature is the delta T, and that's going to determine, and this is what a lot of the questions they just ask, they just say, is this spontaneous or not? And that's it. And so then if you can do the math, you can figure this out. So they're going to determine if a process is spontaneous or not spontaneous, or non-spontaneous, I guess, if you want. So like I said, we spent a lot of time talking about this word spontaneous, but at the end of the day, it's like, does the reaction happen or not? Okay, so delta H and delta S are called a driving force because they determine whether or not the reaction is going to occur. So that they determine whether or not it happens. So they decide whether the reaction is going to be doing anything or not. So definitely a formula that will be on the test. It's given in the data booklet, and so being able to solve problems like this, very, very important. So delta H and delta S units should both be kilojoules before calculating. Now, this is a really small little blurb that's really important because if they're not in the same unit, you're going to be off by a factor of 1,000. So what we normally do is we normally take the delta S value that you get, and then we convert your delta S value into kilojoules. And then you're going to do that by dividing by 1,000. And so this is something that can pose problems. So that's kind of an important little bit. So, all right. Could have a question as simple as this, but if delta G, if the delta G is negative, right? If delta G is negative, this is kind of what we're looking for. If delta G is less than 0, then that's going to be a spontaneous reaction, meaning that it is going to occur without your help, and these are reactions that are likely to happen. If it's greater than 0, it's going to be not spontaneous or non-spontaneous. It means it's not going to happen unless you give it a bit of a bump. And then if it's at equilibrium, which is delta G is exactly 0, which is very, very, very rare, then it's in equilibrium. So what equilibrium means is that the reaction has stopped and the forward reaction and the reverse reaction have kind of come to the same rate. And so the reaction is not doing anything anymore. We'll talk about equilibrium in a different chapter. So now we're going to look at how do these variables affect spontaneity. Okay, so how do they affect spontaneity? All right. Here's a chart, but I just want to, you don't want to memorize the chart. I want you to understand that you can figure a few of these things out mathematically. And so here's the things that are good for spontaneity. So for a reaction to happen, so what a spontaneous reaction wants, what makes a spontaneous reaction quite happy are these things. Spontaneous reactions are going to want negative delta H, which is exothermic, means it's giving off heat. That's a good thing. They want randomness or disorder, which is a positive delta S. So it doesn't matter what the temperature is. These are the things that spontaneous reactions like. Well, then, of course, there's the opposite is going to make it very hard for a reaction to work. And these are things that are going to really make our spontaneous reaction sad and not work. If you are absorbing energy, well, that means that the reaction needs energy in order to happen. So that's not good. Or if it's becoming more ordered, going towards the solid phase, away from the gas phase, these are bad things. So before we even look at the chart, these are things that are going to pretty much give me spontaneous yes, and these are going to be things that are always going to basically be a no. But let's look at the math about it real quick. So let's look at the one that's always works. So this one is the one that always works. So if I play with that one and I use the formula, so when I say formula, I'm talking about this formula here, delta G equals delta H minus T delta S. If we look at that equation, if we don't have any numbers, we just have the idea of the sign, we can still figure this out. So let's look at this. If I put a negative number in here, make that negative, we'll make it real easy. Just make it -1 minus, and then let's just make temperature 1. And then let's make delta S positive 1. Well, look, think about what happens here. We have a minus value, and then we are subtracting, see, -1 minus another 1. This is going to equal -2. But it doesn't matter what numbers you plug in here. If you plug a 50 in there or a 2000 in over here, it doesn't matter. This combination, a negative delta H and a positive delta S, is always going to result in a negative sign. So this is always going to work. So this is always negative, which is always spontaneous. Every single time, because we get this negative number no matter what we put in. Okay, so that's the top one. Now, if you look at the one that never works, we can play with that one real quick too. So if we play with the one that never works, I'll just change it real quick. Delta G equals, and I'll put in a plus for the delta H, so we'll put in a +1, minus temperature is a 1, and then a -1 for the S. Now look at this, +1, right? So the +1 and then minus is plus. This is a +2. It's never going to work. It's always going to give us a plus for the delta G, and the plus for the delta G is never going to work. It's going to be not spontaneous every single time. So this is not spontaneous every single time. So you need to be able to plug in the numbers. And if you get this positive delta G, it's not going to work. If you get a negative delta G, it's always going to work. And so when you're going through this, the variable that can throw all this off is temperature. So sometimes you have a mix that are not always going to work or always not going to work, and that's where you have to look at temperature. So in some cases, maybe it's a plus and a plus or a minus and a minus. Then sometimes it's going to work at high temperatures and sometimes at low temperatures. So this chart is interesting, but if you understand what always works and what never works, you really do better off. So, and we're going to look at that here in these problems, because we're going to look at how does temperature affect things. So